That training software at RAF Shawbury was originally written in the computer language BASIC. Now, most micros come with BASIC built in. It's popular because it's fairly easy to understand. Well, here, for example, is part of one of the listings from the Shawbury programme, and there we are. You can see it's even got English words in it like if, print, and input, and so on. Of course, the microprocessor chip inside the computer can only carry out very simple instructions like comparing two numbers or moving a number from one part of memory to another. So when you run a BASIC program, not when you type it in, but when you run it, it's converted into those simple instructions, or what's called machine code. Now, although the machine code is very fast, the translation process takes some time, so BASIC runs rather slowly. But of course, there are other languages you can use on a micro. We'll have a quick look at a few, starting with Pascal. Now, the top listing over here is in BASIC, and the bottom one is Pascal. And both of these are programs to multiply two numbers together and print out the result on the screen. Have a look at the BASIC first. Well, the first three lines we've got here, line 10, 20 and 30, just set up three variables. A is a number, B is a number, and C is the answer of A times B. Now, line 40 here prints out a bit of text, the answer equals, and the result C. Line 50 just ends the program. Now, the Pascal listing, first of all, you notice that Pascal hasn't got the line numbers that BASIC has. This doesn't seem to be working, but never mind. Hasn't got any line numbers, none of those 10, 20s, 30s, and so on. Also, at the top here, the program has to have a name. In this case, it's called multiply. And there are the variables here defined at the top. Variables A, B, and C, those are the letters we're going to use, and they're integers, they're whole numbers. Then here comes the program. It's surrounded with these begin and end markers. And the guts of the program in the middle here, much the same as the BASIC, except they use the word write line instead of print. Now, the major difference for the programmer is it makes you think in an ordered manner. Once a program segment is written, you've got to think of it as a block. You can't just dive into the middle as you can with BASIC. Now, Pascal is being pushed as a very good language for education because it forces you to think in that structured way. But there's nothing to stop it being used for other applications. For example, it's one of the in-house programming languages for Apple computers.
Logo is a language that was specifically designed for education, and it's often used with a turtle like this. It's particularly good for teaching the simple concepts of programming and mathematics. At the same time, it protects the user from some of the raw edges of computers. Now, it can also be used to produce screen graphics, and this complex pattern here is the result of a very simple program, and it shows very well how Logo enables you to build a program step by step. The basis for this pattern is a square. So the first thing you do is define your square. You do that by saying repeat 4 times the action of going forward by the length you're going to go forward. You haven't yet stated what that is. And when you've done that, you turn left 90 degrees. Repeat that 4 times and you've got yourself a square. So then you can incorporate the square into the program, and the program reads here, repeat 36 times the square, and it already knows about that. Now you define the size. It's going to be side 200, and after each square, turn left by 10 degrees, and then you repeat that 36 times. And if you see the program running, you'll see that actually its makeup is very self-evident. There you've got 36 squares turning themselves into a circle.
Now, one of my favourite languages is Forth. It's available for most micros, including the Electron here. Forth was originally devised to control radio telescopes like this one in Kitt Peak, Arizona. But these days it's used for everything from washing machines to the computer control of movie cameras, for instance in the film Star Wars. Here's how it works. If I type in this word VList, I get a complete list of the Forth vocabulary, all the words that Forth understands. In fact, I'll hold it there. All of these down here are built-in Forth words, standard Forth words, except for this one here, hi, which is one that I made up myself. Now, if I type in hi, you'll see what it does. Prints a friendly greeting here, hello and welcome to Micro Live. Now, the beauty of Forth is you can build up new words using the words it already knows. So that's what I'll do. I'll define a new word which I'll call big hi. Definition starts with a colon. The word is big hi. What do I mean by that? Well, 100 times, starting at 0, do the following things. Just do that hi program, print out the message, and that's a loop. And that is the end of the definition, and that's a semicolon. Now, as soon as I press the return key, that little program is turned instantly into machine code. Shazam. OK, it says, what next? Well, next we'll do it by just typing in big hi, And there we are, very friendly greeting 100 times. Big High is now part of the fourth vocabulary. So you see, fourth can be extended to do whatever particularly interests you. Traditional software writing involves the programmer in breaking down a problem into manageable procedures. But an alternative approach, well, for some applications at least, is to chuck the problem to the computer and leave the machine to sort it out. And for that, you need a language like Prolog. Now, Prolog stands for Programming in Logic, and this is a version available for the Spectrum. Right, well, I've been telling the computer here about a bicycle. For example, I've said in the program, the electric flex is part of the lighting system. The hub is part of the wheel, the gear cog is part of the wheel, and the spoke is part of the wheel. And I've also told the machine about the relationship of those parts. For example, X is part of a bicycle if X is part of the wheel. Makes sense, doesn't it? And down here, I've typed in a question. Is the hub part of the bicycle? Now, I've not explicitly told the computer that it is, but I'll press enter, see what it makes of it. The machine goes away, and yes, it correctly infers from the rules I've given it. The answer is yes, a hub is part of a bicycle.
A lot of applications nowadays are being written in a language called C. It's very fast and it's portable. And that means that you can run a C program easily on a range of machines. Here's a listing of a simple C program on the Nimbus to print a table of temperature conversions from Celsius to Fahrenheit. Now, this was all typed in on a word processor. To turn it into a program that the Nimbus can run, it has to be compiled. That means running another program that converts the text into Nimbus machine code. But this listing could be compiled to run on a number of machines, and that's what makes it portable.
So, which is the best language? Well, unless you're a professional programmer or you want to do a very specific task, one general-purpose language like BASIC will serve almost all your needs. Now, recently it's become fashionable to knock BASIC. People say it leads to bad, unstructured programming habits. But BASIC can be used in a structured way, and it's fine for most applications. But of course, it's horses for courses. Hugh Farringdon School in Reading. 650 pupils aged between 11 and 18, and the location of an important experiment in education. Claire Tester, the school's head of music, has been taking part in a research project with Reading University. The aim is to discover whether a music-playing home computer is fit to join conventional musical instruments in her classroom.
Right, 1Z. What I'm going to ask you to do today is the next part of our project. You're going to make up a melody that you can repeat over and over again. The only rules are it must last for 4 beats, and you may only use the 5 notes on the board, E, F, G, B and C. Got that? Right. Will you please go to the instruments that you're using? And you've got 1 minute to make up something really interesting from now.
The interesting thing about Claire's work is the way she's integrated the computer with the more traditional instruments in the classroom.
Right, do we have any brave people who are going to play us their tune? Good, lots of you. Right, let's have Alison, Kathy, Mark. The rest of you listen carefully because we've got to choose one of these. Okay, Alison, would you like to play yours twice now, please? Thank you. Kathy, now let's hear yours. Another good one. Mark. Difficult choice. Okay, who preferred Alison's? Good. A few of you. Hands down. Kathy. Good. Hands down. Mark. Right, that's obviously the majority, isn't it? Right, hands down. Mark's is the first tune that we're going to use in our computer piece.
The computer has been specially designed for creating music.
When using the composing program, the computer will take in any number of up to 8 parts that you program into it, and then it will play it back for you. It's very simple to actually program. There's a selection of the note values here. Then here we have a conventional computer keyboard. Here is a piano keyboard, which you can use either of these to program the notes. For example, I'm going to use some crotchets. I'm going to program in, using the piano keyboard, a series of notes. Now the computer will play that back for me. Now that sound that you've heard is a sound that the computer itself has selected. I don't have to use that sound. The computer has 46 pre-recorded sounds of its own. Among these are instrumental sounds, or it has a large number of actual sound effects. Not only will it play back to you any of the melodies that you put into it, but it's a very simple operation to edit the melodies that you actually write, which means the composition can be changed very quickly. When you're finally happy with this, at the touch of a button, the whole thing will print out.
When it comes to printing the notes, it scores badly. Here it's making heavy weather of just producing one line of a stave.
Okay, Mark, now we're going to program your melody into the computer. So yours will be the first one in our composition. And the first thing you need to use are semiquavers. CF. Quaver. G. Crotchet. E. Quavers. GC. Crotchet. B. Good. Now make it play for us.
The computer's better because it can store things longer in its memory than we could. So if we had a couple of weeks to remember it, we wouldn't have remembered it in a couple of weeks.
It's a bit of a shortcut because you're using like a guitar or a drum and playing it on a keyboard. I would prefer to learn how to play the instruments. I think it's better than actually playing it on a keyboard.
When we first got the computer, I thought, well, all the good musicians and everything will take over the job of working it, but it's easy to work and everybody was allowed to have a go.
What I think is the only disadvantage with the computer, and that is that it will only display and or print one part at a time, even though it can play up to 8 simultaneously. Now, the first years created a composition that was really quite complex, and it was important for them to know what went on in the composition and to be able to view it as a whole, which of course we couldn't do. So they created a score of their own, using their own symbols. They used all sorts of things from hands to traffic lights, and it meant that although it was a rough idea, they could get an overall picture of the composition. When we first had the computer, we used it virtually non-stop. But interestingly enough, they did begin to miss playing the music for themselves after a while, which meant that we came up with a balance of actually playing the instruments on top of the computer in the background.
With the introduction of the new GCSE music syllabus, greater emphasis is being placed on creative composition. But until now, creativity has been stifled by the need to acquire playing skills. Now, using the computer, any child can play a piano, organ, trombone or drums and express creative ideas.
Ladies and gentlemen, welcome to the first public performance of a very important composition created by 1Z. Every note that you see and hear has been composed by them using a combination of a computer and live instruments.
I like playing live in the middle because if we didn't, the computer would have sort of been taken over.
I think an excellent way of assessing the success of any new teaching aid is to ask yourself the question, would I still use it if I had to carry it up 3 flights of stairs? With the music computer, the answer is definitely yes. It's added a completely new dimension to the teaching of music in this school.